All right, 2 weeks left. 2 weeks. We have an assignment this week, and then we have one next week, and then a final. Quit giggling. It's not that you will miss me. You know that you will miss me. Did you really? Nice, Reese. Good. Nice. All right. So, donut sales in the classroom are alive and well. If you buy 2 dozen, Reese, she's up to 50 dozen donuts. All right, so let's talk about this week. There are a couple of things to do. Nothing horrible, I hope. It's not designed to be that way. So week 14 should have chapter 14. You do have a choice of one of these. You do not have to do all of them, but 14:1, 2, 3, or 4. There is a case project in there for all 4 of those at the end of the book. So you can pick and choose and figure out which one you would like to do. There is a crossword puzzle that gives you no points but can be kind of fun. There's 2 lab simulations, and those are pretty short and sweet. They're not very long. And then there is a quiz somewhere stashed in here up top. The discussion board, let's talk about it a little bit. So I have you researching security exams, but I'm also going to add something for extra credit, because I know a lot of people are missing an assignment or 2. So here's what I would like to do for extra credit. I want you to explain one assignment why you didn't do it. But I don't want you to tell me the truth. I want you to make the biggest outlandish lie about that assignment that you can possibly make. And the better the lie, the more I laugh at it, the better your grade on one missing assignment will be. So tell me which one you're missing, and tell me some outlandish reason why you didn't get it done. If I sense any truthfulness, I will not give you credit. So I need the biggest, most outlandish lie you can possibly come up with. On week 14. So you still have to do the CISSP and find one similar, but then for some extra credit to count for one of your assignments, and I'll write it in there because I just thought we'd transfer it in there, so I will write that in there as soon as I can. I want to lie. A big, fat, juicy, make me fall on the ground laughing lie. You know, like the ones when you miss class. No, I'm kidding. So, come up with something entertaining, and that entertainment value, you can replace one of your missing grades with it. No. That should make life a little more interesting. And I will, at the end of the class, I will try to write that up really quickly. So I did it in another class, and I'm like, yeah, let's do it here also. Why not? All right. So we have a couple of assignments in here. Look at that, week 14, week 15. So there is a final in here. So the good news for you guys, or bad news, depending on how you want to look at it, I will not require you to come to take the final in class. I will have it available online. It's a hybrid course. It just makes life equal or equitable for everybody. So I'm not going to torture you. The downside of that is usually I have donuts or something available, like I bought already, but it probably will make everybody's life a little easier. So I'm going to guess most of the finals this weird semester in pandemic are going to be online. So you do not have to worry about the final being here on campus. So you only have today and Thursday and then next week to see me in class. All right. So let's talk about this last chapter. And as somebody pointed out, there are a lot of overlap between this and the 310 class in the last couple of assignments and last couple of items, because we're really talking about some very similar things. So what we're talking about is the idea of, all right, we come up with some protection ideas for viruses. We've come up with some documents and try to deal with our employees and what stupid things our employees are going to do. Because quite frankly, I think one of the things you're going to discover as soon as you get out of college, if you haven't already discovered, is people, especially when you get them in small groups or large groups, can do amazingly dumb things. And you're going to go, wow, how do I fix what people are going to do that is dumb? So business continuity is that idea of how do I keep my business or my organization or my college. There is. People will go traitorous. They get a different job. They try to do bad things. How do we stop that? But I want to keep my business running. I love the idea of business continuity. So how do I plan for it? How do I figure out what's going to happen in a disaster? And how do I think about what's going to happen in the future? And some of your parents or you may own businesses, and so you may also start thinking about some of these ideas in your own lives. So, business continuity planning then is planning for the future. So how do I figure out what is a threat, what isn't a threat? How do I determine that we have enough resources and they're in the right areas? How do I recover from some kind of a disaster? Whether it's man-made, it's people. And think about this last couple of years with this pandemic. How many businesses have you seen fail already? There's been a lot of businesses fail. And now we're trying to keep them in operation. And what do we see weird around us right now? There's a lot more jobs open than people are willing to take even. So right now, the Auburn in the Sonic is open from 10 p.m. or 10 a.m. till 8 p.m. because they can't get help. And so we're seeing, how do I work on those kinds of details? How do I deal with personnel shortages? How do I deal with crisis? If I don't have enough employees, do I just shut the business down for a couple weeks? For most businesses, that's not an option. And so we need to figure out what kind of strategies and what kind of methods we can do. So, business impact analysis is a term that you may hear. And it's that idea of what is the impact on my business if something happens. So, the impact of COVID, has it had an impact on property, on tangible assets? I would say it has, because it's driven up the prices of some properties, some it hasn't. But if my business has property, has COVID affected it? Probably not as much as some of the other things we're going to look at. Has it had an impact on finance, though? Has COVID had an impact on the finances at this college? Yeah. Do you guys see as many students right now? And I don't really blame a lot of people, because we don't know what's going to happen. And until we get the vaccine, more people have it, and it really seems like it's going to work. If I had a student going to school, I might say, hey, let's stay home and go to school via telehealth or virtual instead of doing it on campus. So it's had an impact. It's had an impact on a lot of businesses. What about safety? Well, 565,000 people in the U.S. have perished from COVID. I'm going to say it's had an impact on safety, and we see a lot of changes. We took our computer lab that had 30 people down to 15. So when we enrolled students, so we had less capacity. Well, that impacts finances. It impacts safety. We've went around and put signs up so you can only go up some stairs, down others. So it's had some impacts on safety. What about reputation? Has COVID had an impact on reputation of different businesses? I think we've done pretty good. But if suddenly a school has a large outbreak, does that impact their reputation? Yeah. If we had a big cyber event on our campus, that would impact their reputation. And that well-being, how do I deal with the overall function of our business? So one of the things we're trying to do is establish, what is that core of the business? What is critical and what is maybe less critical? And so we had to make some very quick turnarounds. We went from, hey, it's spring break, to, hey, we have an extra week of spring break, to, hey, don't come back. And so we had to identify what things were mission critical. Some of our classes were easier to transition over than others, but we were trying to put everybody's health and well-being as one of those very critical things. So we start thinking about this idea of something called a single point of failure. What can cause the most issues because if it fails? So when I think about a business system, what could this college not live without right now? I think Wi-Fi might be a piece of it. What if we didn't have network connectivity outside of this college? Could we function? What about Blackboard? Is Blackboard now an integral part of our system that we have to have? Yeah, I would say so. What about financial aid? Is financial aid important for a college to survive? Yeah, if you look at our numbers, I think the last number I saw was 73% of our students receive financial aid. So I think it's important. So we have to look at what functions are important. Maybe we think the coffee shop is not important when we're in the middle of a pandemic, right? So we prioritize what things are important. So in there, we a lot of times also do things about privacy, because we're also looking at what systems have information that is critical and valuable, that PII or personal identifiable information or healthcare information, those kinds of things that we can't let escape. So even though we may have a disaster, we need to contain that information really, really securely. So that leads us to a DRIP. That idea of a plan to recover then from whatever has happened. And I want to think just outside of IT. I want to think of that entire company. How do I bring that company back once we've had some kind of an issue? So whatever that disruptive event is, a tornado, a cybersecurity event, a fire, a flood, the pandemic, our disaster recovery plan has ways that we can try to recover that data, restart our processes, go back out on the road recruiting. Now high schools are back in session for the most part. Most sessions are live. We can go start doing recruiting again. So how do I figure out what those processes are, and I create a recovery plan? So this one needs to be updated. So generally 6 months or every year you update your recovery plan. So a couple of things that are going to be in there. So typically we think of a disaster as something that happens very quickly, and certainly COVID happened very quickly. So we need things like what are we doing with our plan? How do we prepare? Procedures. And we've learned a lot of different things. Even in terms of all of our systems, if we had a tornado on campus, which ones do we need to bring up first? How do we sequence what needs to happen first? So certainly systems related to people and payroll are probably high on the list. If I have people that have been impacted by a flood or whatever we have disaster here and they're not getting paid, I'm probably not going to see them around very long. So I need to have some way to bring systems back online and to make sure that that data is still valid. So if we had a tornado that wiped out half of our campus, we might relocate some facilities in Auburn or Nebraska City temporarily. I need to make sure that data is available. And then once we're back up and running, we need to make sure that it actually works. So one of the things we need to do is make sure we test this idea. And testing that idea can get very convoluted because we have what we call a tabletop exercise. We talk about it, but what we really need to do is actually do an exercise. And so you've seen them where we bring in and we pretend we have a fire and we'll have people being temporarily sent to the hospital. But we also need to do that with our data. And our data then, we see what happens and it gives us a plan afterwards. We say, oh man, We know what things we should have done better. And in a lot of cases, we actually test that data live. So we say, we're going to pull the plug. We want to see what actually happens. Do we have backups? Do they work? But that after effects can tell us what we did wrong. So before any of you guys went to Peru here, we used to do it more often. And it's interesting, I don't see us doing it very often now. We used to do fire drills all the time. Not a bad idea, and if you went to high school, you probably did fire drills. We had one and a big one, and everybody's out front. We're trying to figure out who's all accounted for. And we noticed that there is an issue. Guess who we did not bring out of the building in a fire drill? All the classrooms came out. What's down in our basement? Nobody got the Tiny Tots children out for a fire drill. Kind of embarrassing. And so we look at those procedures and say, all right, now we know next time we need to do better. What can we do better? And how do we improve that? So these exercises, I know sometimes they seem silly that we go through these, but it really does tell you what your strengths and your weaknesses are. So they're expensive, but it's a way to do things. And sometimes we find out things we didn't want to know. So one of the organizations I've had some consulting with, they put all their data, and we'll talk later on about data backups, but they hired a company to do their data backups. Well, that makes sense. This company says, hey, your data is all secure. And we said, well, can we prove it? Can we say, we're going to cut off data and I want to back up data from a week ago and reflush the system and make sure that we really can recover that data? And they said no. Wait, what? So as it turned out, they hired a company to do data backup for them, but they weren't able to access the data at any time and when they needed to. If they had a breach, so we had an event, they were able to access it, but it came with an additional cost, and nobody had ever noticed that. And so for a true data breach, or if they needed to go back and back up data from these guys, it was an additional $150,000. They did a one-time, essentially close to half-price sale for, I believe they spent $90,000, so we could do an exercise to see if we really could get the data back. And we could, but it really didn't give us that warm, fuzzy feeling of, hey, I can get my data anytime, right? So since then, they've developed some new data plans, and they're storing data a lot differently. They're storing it in multiple locations, and it's all accessible at any time. So, in addition to this idea of disasters, normal wear and tear causes issues. Things break over time. Has anybody had a car that never needed repairs? No, I wish I had one. But every vehicle you have is going to, at some point, need some repairs. That's just the nature. Computer hardware also, at some point, is going to break. Things do wear out. Things break. The most common thing that breaks are hard drives. Because on the servers, we're still using old-style spinning drives in a lot of cases because they're cheap for the amount of data they can store. Well, one of the ways we do that is duplicating equipment so that we have duplicates. So if I have a server, and I can't do it with COVID, but if I crammed you all in our back storage closet and you looked at the server we use in here, you'll notice it's got a lot of duplicate hardware. It has two power supplies. Power supplies are one of the things that do fail. It's got two power supplies, so if one fails, the other one takes over, and we don't lose that computer from operating. In fact, the server back there actually has a redundant piece of memory. It's got some extra memory, and if we have a memory fault, it switches to this extra pair of memory and continues on, and you don't notice it. Hard drives. Hard drives fail. We replace them, that machine, you never notice it, that they happen to go. Most of them, we have multiple redundant hard drives on that server, So it swaps in a spare. You don't notice that anything has happened. So, but we also need to think about other things. Power. Where am I storing my data? Do I have actual physical more servers? Because if I have a specific server and it goes down, especially right now, you can't replace it in the next week. It's going to be several weeks to get that. Network hardware, so higher end network hardware like some routers. I've worked with an organization we're trying to order, and the vendor is telling us that they are 60 to 70 weeks away from producing because there's a chip shortage from such high demand and some of the factories being down. So some of those things you may think about and say, well, man, maybe I should have a second router on site ready to go if I need to. Yes, it's a lot of money, but how much money would you lose if you were unable to get on the internet for a month? So we need to look at that in context. So our servers are typically one of the things we talk a lot about. How we put them together, typically it's not one machine. So I'm going to guess on our campus we probably have 50 different servers. How do we combine them? How do we use them? And so in a lot of cases, we use what's called a cluster. So there's a term you'll see here called a cluster. And a cluster means they're working together. So there's multiple machines. You don't notice it from the outside, but from the inside, it shares that load among multiple machines. So here's this idea. Here's all of our clients. We have something here. Here they call it a public cluster connection. It could be a load balancer. It could be a server working to divide that. But we have multiple servers in a pile. And so we're able to share that information, and we're able to balance that load out because one server can't do thousands of web hits a second. But if I have enough of them, then I could be like Facebook, and I could have that up. This also applies to things like MyPSC. So MyPSC actually hits two different sites. It hits UNL, and it hits one over at the Med Center. So if one of those sites for MyPSC goes down, the other server can maintain it, and they share data, they replicate data back and forth nearly constantly. So now we have more and more and more storage. Everywhere we have storage. Our computers are getting bigger, we're storing more data. One of the things that's happening, most of your computers, you buy them now, you get a solid state drive. There's no moving parts. Well, servers are moving to solid state drives also, but at a little slower pace because of the price difference. When you're trying to store 60, 80, 200 terabytes of storage, solid state gets pretty expensive. So hard drives fail. Solid states in servers are really not that much more reliable, I have to tell you, because of the number of reads and writes they get. They actually wear out also. They're significantly faster, which is what their big advantage in a server honestly is. So I'm going to say that all organizations should keep spare hard drives on hand for that particular machine. Typically in a cluster of drives, you have 1 or 2 or 3 that are set up as spares. And there's some numbers you're going to see. So mean time between failures. So this is where math gets a little weird. So mean time between failures. Most hard drives will say, hey, I've got a mean time between failure of 100,000 hours. Well, that's a long time, right? The problem is when I start putting them together, and so if I had 100 drives, I've actually reduced that by a factor of 100 because it's one device can fail in 100,000 hours. Think about it as a fraction. So then I have 100 over 100,000, and I have decreased that failure time significantly. So organizations like Google, with their data centers up in Council Bluffs, they have drives failing literally every hour. because they have so many servers and drives. And they've adopted the model that they have enough servers, they just literally shut a server down, walk away until it's regular maintenance time. Well, if you only have a couple of servers, then it's a little harder to do that. But one of the things we can do is we can take those numbers and we can say, all right, I know that I need to have in this cluster, I may have 5 drives working, and I keep 2 of them in that drive as spares so they can swap in automatically so that we don't have any disruption of business. And then when that does, it generally will alert you in some way that you can say, all right, now I need to replace those physical hard drives. So there are a lot of resources about how long drives last. So one of the best ones is something called Backblaze. Backblaze is a storage group. They store all kinds of data for all kinds of individuals as long as they're willing to put it out there. But what's interesting is they publish the statistics about how often they have drive failures, what models, what brands, and how that works. So it's kind of a nice touch. You can actually access a company's data. Google's not going to tell us, but Backblaze will in this case. So we talk about multiple drives. One of the best innovations we've had is the idea of something called RAID. A redundant array of inexpensive was actually the original term, but independent is also the term you'll see. Drives. So we can do them a couple different ways. They can be software, they can be hardware models. But what it essentially does is through some kind of a controller, it says in this case we have 4 drives. I'm storing part of drive 1 on drive 2. Part of drive 2 stores on drive 3. Part of drive 4 stays on 5, etc. So that if one drive fails, I can recreate that data because it's all stored somewhere else. All right, so there's different types of data storage. So RAID 0. RAID 0 is purely for performance. And RAID 0 is a little frightening because instead of storing all of your data multiple times, it's striped across all 4 drives, but it's not redundant. So RAID 0 is kind of a scary model. Great for performance, bad for reliability. So there's no fault tolerance on RAID 0. The opposite side of that is what we call RAID 1 or mirroring. So RAID 1 says we completely copy everything from drive 1 onto drive 2. And here we copy drive 3 onto drive 4. So it's in some ways the most duplicated, but it's also the most expensive because if I want to have all my data duplicated, I essentially have to buy 2 times the amount of hard drives I would normally buy. All right. So somewhere in the middle, we get something where we start at RAID 5. And RAID 5 says, all right, I have what we call these parity bits. So in this case, I take pieces of data from all the other drives, and I put them on here. And I take, on B drive, I take pieces of all the data and put them here, and here, and here. So we're taking data from every drive and shoving it in on there. And so RAID 5 says I have n minus 1 capacity. So if I had 5 1 terabyte drives, I have 4 terabytes of usable capacity because I'm using that other portion to move to all these other drives. And in this case, if drive B died, or the second drive, or number 2, whatever, I put in a new drive, it grabs those parity bits from all the other drives, recreates it, and we're back in business. So there's some other models. So there's RAID 6, RAID 10. There's RAID 0 plus 1. So RAID 0 plus 1 is one we kind of use sometimes at the baseline for our server where we have 2 sets of data and we stripe them from one to the other, but we're also using the capability of RAID 0. In other words, getting massive amounts of data out at once. So this is very expensive because now to get the same amount of data, I need 4 times the number of drives, right? Holy cow. So very high data writes. So Outward-facing servers sometimes use this, Exchange servers, because we can push out a huge amount of data very quickly, but it's less efficient in terms of size. So here's kind of a list of a couple of them. So RAID 0 and 1 both need 2 drives. RAID 5 and some of the other models very similar say we start with 3 and we have a lot more drives that we can actually utilize. So it's very versatile. It's used a lot because it doesn't waste a huge amount of space. We can increase the number of parity bits, and we'll show you what one looks like. I'll log in and show you what something that looks like. So if I have redundant drives, I probably need redundant networks. And so a lot of times we actually have duplicate networks, duplicate cabling. We may have a building that's got a circular path with a fiber. So anything we can do to duplicate, that just allows us to be a little more secure, because we can find that way to get back up and running a little quicker. And so we'll leave you with the idea of data power. And around here, power is an issue. Power is a big issue. We lose power all the time here in Peru. How do I stay up and running? Well, the first line of defense is something called a UPS, or uninterruptible power supply. And if you look on your desks in here, we actually have one on each desk. And part of the reason we did that was we lost power often enough, and we had some other issues. We have a UPS here. So the cheapest one is something called an offline UPS. It doesn't turn on and pull power from the battery until it loses power. So it works really well for that use. If you're going to buy the $50, $60 UPS, that's what you get. And as soon as you get primary power back, it flips back to just sitting there and looking at you. The ones on your desk, though, are what we call an online UPS. So they are always running off the battery. So the voltage comes into the unit, it charges the battery then runs an inverter, and the advantage to it is it can correct the voltage. And one of the things we had in this building was we had some voltage issues. Once we put these in, we can run that voltage to 120 volts continually, even if the voltage feeding them rises or falls. So UPS systems are great. Problem is they have limited runtime. So typically something like this will run your server or your desktop computer 5 to 10 minutes, enough to shut down if you need be, or have something like a backup generator that comes online to then take that load up. So around here, most of our generators are propane or natural gas. You can also get diesel. On our college campus, it's hard to have enough power. So when we have a backup event or we have a power outage, the only buildings we can run are the AWAC and the admin building. So you do have to be a little bit careful about how much you're trying to run off of those. Most of the time, you're not going to run a lot of HVAC equipment, and that's going to cause you a little bit of an issue. All right, so let's see if I can remote in here real quick. So let me hit the pause button.